and what is LoRa and what is LoRaWAN and what is DHT11, and finally, like we are going to see how the project works, and we are going through the code line by line. I'll explain you the code line by line, and then like we could download the program on this Cortex M4 board, and we could verify this project. Okay, so these are the things which we are going to learn today. I'll give coming to the mindset lesson. Like we'll start the day with the mindset lesson. Like, don't blame on the circumstances. Okay, look for the circumstances you want. If you can't find them, just make them. Okay, so this was the quote which I'd really like to share. So you have to make your own circumstances, and you have to find your own way to achieve the success. Okay. So don't blame. You have no rights to blame on others. If you want to be more successful, if you want to be successful, then you have no rights to blame on others. Okay. So you have to look for circumstances, and you have to look for the idea. You have to look for the way where you want to go. So this was the lesson which I would like to share. With this, we'll go for the topic. So today's topic is on temperature monitoring using LoRa module. This is the board, like the Cortex M4 board, which I'm using it. And these are the two LoRa modules. Okay, I'm going to interface one module with the Cortex M4. And the other module I have interface with the FT232 board. FT232 board, and I have connected this to my laptop. Okay, so you could use two LoRa modules, or you could use 3 or 4 LoRa modules, and you could connect it. You could transmit the data to the LoRa modules or the gateway. Okay, I'll explain you like what is LoRa and how LoRa works on the next slides. Like, but in this project, we have a DHT11 for measuring the humidity as well as for the temperature data. I have interfaced this DHT11 on the port, the GPIO port, and I have interfaced this LoRa module. It is a serial port based UART module. Okay, there are a lot of interfaces are available. Like you have I2C LoRa module, you have and SP based LoRa module. The one which I have used was UART, serial port, and the price of the LoRa module comes around, like one module price comes around 900 rupees. Okay. And this DHT11 you will get it for 100 rupees, 100 or 80 rupees. 150, sometimes 120, okay, depends upon the shop. So these are the hardware details. Like I have used ARM Cortex M4 LPC4088 board, and I have used two LoRa modules, and one DHT11 and one FT232H module. This is the FT232H module. The price will comes around 150 rupees. Okay. And the software details, like you need the Kale version of ARM Cortex, the hyperterminal software, and FlashMagic software programming. Okay, so these are the softwares which you require for this project. So and features of LoRa. The LoRa which I have the purchase was the serial port module, and it uses the center frequency of 868 megahertz. Okay, 868 megahertz, and it could transmit to a range of 2 kilometers. Okay, transmit a range of 2 kilometers. And it is it's unlicensed version, like free one, and you could integrate with RS-232, RS-485, 422. Okay, the model supports TTL serial data. So like it could be directly interfaced with the microcontroller, and it is compatible to 5-volt power supply as well as interface. Okay, and it also has the 16-bit node address and 16-bit network. It also supports 16-bit node address and 16-bit network address. So point-to-point communication as well as the star topology is also possible with this module. Okay. So the range is 2 kilometers outdoor with open air with node-to-node range. So these are the features of LoRa module. And the pinouts, if you check out the pinouts of the LoRa module, like you have the ground pin, you have the VCC pin, and you have this 5 DC, like I'll show you on the 5 DC and CTS, TXD, RXD, and prog. Okay, prog for programming mode. So if you want to see that on the hardware, like I'll show it on the hardware. Okay. So if you check now, if you check, this is the module. This is the module, like module which is connected. Like you could you could get the pin details here. Okay. You could get the pin details. You could get the pin details here. Okay. So the first pin is ground. This pin is ground. This pin is ground. So you could get like it is printed in the it is printed in the legend. So you could easily connect this one. And pinout of 5232, like you have ground, CTS, VCC, and TX, RX, as well as the DTR pin. Okay. So this is for the pinout of FT232, which is used to connect for, because one LoRa has been connected to this FT232 module. The other end of the FT232 module is connected to my laptop. Okay. So I'm going to transmit from microcontroller to my PC via this LoRa module. Okay. So this LoRa module, like you could use it for windmills, you could use it wherever for RF communication, like the RF communication, you could use this one. So coming to this DHT11, like it uses the pinouts of DHT11 is like you have it communicates on a single wire, like you have VCC pin, data pin, and like not connect, and this is ground. Okay, not in use, and this is ground. So this is the pinouts of DHT11. I will go through the LoRa introduction. Like I'll give you a short introduction on LoRa and LoRaWAN and what are the modules and how it works, and then we can go for the code. Okay. So LoRa, it's a wireless modulation technology based on the Semtech company. Like the Semtech, they have the proprietary chip spread spectrum technique. Okay, it is a proprietary technique which uses the physical layer for long range wireless communications. Okay, LoRa was operated in the license free ISM band all around the world. Like it has different frequency. You could get LoRa modules on 433 megahertz, 868 megahertz, and 958 megahertz, and these are the frequency bands. These are the frequency bands in the countries like European Union, like you have 868 megahertz. At USA, it's 915 megahertz, and for India, it's 865 to 867 megahertz. Okay? Maximum output power could be 20 dBm. 20 dBm. At China, it has 470 to 510 megahertz and 17 dBm. These are the LoRa frequency bands. So you have to choose according to your country. Like the frequency, you have to choose the LoRa module according to your country. So these are the frequency bands available. Like on the LoRa end device, like this is the block diagram. Like you have the LoRa chipset, which could be connected to the application microcontroller, and you have the antenna. Okay, so this LoRa chipset, like LoRa chipset was from the is from the Semtech company. Okay, you have the part number like SX1261, SX1262. I have shared you the data sheet on the portal. But this part number, like this is, if you want to get the IC and if you want to make a module, LoRa module, like this is the block diagram. This is a block diagram, but it is not recommended unless and until if you are a good RF design engineer. Okay? Like the RF design needs a specific knowledge on. You should have a very good knowledge on antenna designing as well as on the PCB layout side. Like RF design, like you have to take special care on making the PCB boards and for EMI shields. The entire circuit has to be shielded by using an EMI filter. EMI filter, like it looks like this. Like this, these are all the EMI filters. Okay, this shield is called EMI filters. So this LoRa, this shield is an EMI filter. So you have to take care of this shield. So unless and until if you are an RF design engineer, like it is not recommended to get the chipset and to make a circuit. Okay, only those who are familiar with the RF design engineer can do this job. So this is just for your reference, like how the LoRa module works. Else, you could purchase these modules. Okay, you could purchase this LoRa modules, which is available on the market for 400 to 500 rupees. It starts from 400 to 500 rupees, and you could get it for even for 900. Like the one which I bought is 900 rupees, which has UART module. The SPI module is available for cheap for 400 to 500 rupees. Okay, so how it works, like LoRa, how it works, like how to transmit data from one module to another module. So you have the LoRa module here, like it is interfaced with the microcontroller. This microcontroller can be interfaced with the sensor or sensor data, sensor or actuators or power management. This module, like it sends LoRa node 1, like it could be transmitted from node 1 to node 2. So when the node sends, like every other nodes, all the nodes will receive, but the one which has the if you want to send to a particular node, you have to you have to mention on the packet header, like the to address and the from address. Okay, so the particular node with the ID will receive, and all other nodes will just discard the message. It just discards the message, just like Zigbee. Like LoRa module, like you have the address to transmit. You have to mention that on the packet header, and you have to transmit to the node. Okay, but when this message will be received by all other nodes, but it will ignore. It just ignores the packets. So LoRa programming, like it comes with all libraries. Like you have Arduino, a LoRa library at this GitHub link, and Radiohead, and ESP32 LoRa library. Okay, so you have a lot of programming libraries, and coming to LoRaWAN. Okay, coming to LoRaWAN, like LoRa and LoRaWAN is different. Like LoRaWAN, the communication protocol and architecture replaces the LoRa physical layer. Okay, the LoRaWAN uses the same physical layer of LoRa, and but the communication the protocol is slightly different, and it is open source and it's freely available. Like it supports star topology, and it could connect nodes to multiple gateways. Okay, and it has the addressing it has an adaptive data rate, and it has an improved addressing as well as addressing algorithm, and it has multiple levels of security, which uses the encryption as well as decryption and details. Okay. So coming to the LoRaWAN module, LoRaWAN module will be separate, and like all LoRaWAN module, you have to check whenever you purchase the LoRaWAN module, you have to check whether it supports the LoRa or not, because some of the LoRaWAN modules will not support the LoRa protocols. So you have to check you have to check while you purchase the module, LoRaWAN module. Okay. So the LoRaWAN module can communicate with other LoRaWAN modules or the LoRaWAN gateways. Connect. So when joining the network, like it has a 32-bit unique identifier, the device address, and which is used to communicate with the other devices. So these are all the LoRaWAN modules. Like you have to check. Not every LoRa modules are LoRaWAN compliant. So you have to check those modules while you purchase those modules. And this is a simple architecture. You have the LoRaWAN module, and you have the application microcontroller, which could be communicated via an UART. Okay? UART, and this application microcontroller can send AT commands, attention commands for this module, and you could configure this module through AT commands. So AT commands will be on the datasheet. For the module which I have used, I have shared the datasheet on the portal. I have also shared the datasheet of the FT232 on the chipset datasheet, as well as the DH11 datasheet. Okay, everything I have shared it on the portal. And these are the few development boards available in the market for LoRaWAN, for LoRa and LoRaWAN. This is the common architecture. Like you have the end device, and these devices will be connected to gateways, And finally, the gateway is the LoRa gateway. The LoRa gateway will be connected to the internet. Like it is connected to the internet via an Ethernet or by 4G. And this is again connected to the application server. Like you will have it on the gate. Like it may be on Microsoft Azure platform or the ThinkSpeak platform or the Amazon platform. Okay. So this is the common architecture. Sample architecture, you have an end device, LoRa connects to the LoRaWAN gateway. LoRaWAN gateway connects to the network server, and this networking server is connected to the IoT hub, Microsoft Azure. So when you connect to Microsoft Azure or Amazon, like you get higher scalability. So this is the gateway. This is how gateway looks. The LoRaWAN gateway looks, and it forms a bridge between the end devices, the nodes, as well as the network servers. So it communicates the end devices with LoRaWAN protocol, but it communicates the TCP. It communicates the advantage of gateway is it uses two types of communication. One communication is used to connect with the LoRaWAN devices, LoRa devices with LoRaWAN protocols. The other communication is to communicate with the internet via a TCP/IP protocol. Okay? It could use an Ethernet or it could use the 4G or 3G communication by using TCP/IP protocol. It can communicate with the network servers. So it also contains multi-channel LoRa demodulator, like able to decode all type of LoRa modulation variants. Because LoRa has multiple modulation variants. It could so this gateway can decode for all type of LoRa modulation variants and runs on a minimal firmware. Okay, the packet forwarding software. So these are the advantage of LoRaWAN gateway. So coming to this application, like we are using DHT11 for getting the data from for getting the temperature, humidity, as well as the temperature data. And then like this data is sent to a LoRa module, and this LoRa module transmits the data to the other LoRa module, where we receive the data and we display it on the where we display the data on the hyperterminal. Okay, so this is what we are going to do. I have already explained this DHT11 on the IoT class. Like I will repeat it again. Like it works on this, like it works on a single pin communication. Okay, so it uses one-wire communication. Like the communication process is divided in 3 steps. Okay, the first is to send request. You have to send a request to DHT11 sensor. Then the sensor will send response pulse, and then it starts sending data of totally of 40 bits. Okay, it send 40 bits of data. Once you send, like first you have to request the DHT11 sensor to send the data. So that is the start pulse, and this start pulse will be sent from microcontroller. Okay, you have to send from microcontroller. So this pin will be the VCC pin. The microcontroller pin will be in high mode. The high mode. The start pulse it will send the start pulse by making the high pin to low for a certain period of time, like 18 milliseconds. It will make a delay, and it will wait for the response. Okay. After that, DHT will send a response signal. And then along with the response signal, it also sends the data of 40 bits to the microcontroller. Okay, 40 bits of microcontroller. The 40 bits is nothing but it will have zeros and ones. Okay, for bit 0, the load time is 54 microseconds. The high time is 24 microseconds for bit 0. Whereas for bit 1, if you check for this is for bit 0. The bit 0, the load time is 54 microseconds and the high time is 24 microseconds. For bit 1, the load time is 54 microseconds, the high time is 70 microseconds. Okay, so after sending this start pulse, like this is the start pulse, like 18 milliseconds of load time. So the response pulse will have 54 microseconds and 80 microseconds. And the data pulse, like 0 for 54 microseconds and 24 microseconds, and output 1 for 50 microseconds and 70 microseconds. The high will be of 70 microseconds, which denotes it is a 1 bit. So totally it sends 40 bit of data. So 40 bit of data. Okay. So this 40 bit of data will have the humidity as well as the temperature information. will have the temperature information. Let's go for the program. We'll explain you the code. So it uses a standard UART program, and then we can download the program on this kit and we see the output. Okay. So first I will explain you the code. So the first thing is like this is quite big, so it's very hard to type this code. Like it will take time. It will take time. So I will explain you the code. And the UART concept is same. Only the DHT11 is different. Okay. The first thing is to include the header files. Include the header files for LPC 4088. You have to include stdio.h for using printf statements. Okay. So by default, it prints the data to UART 0. By default, the printf statement. If you want to push it to other UART, then you have to reconfigure. Econ is the printf statement. You have to reconfigure the internal files. By default, UART, when you put printf on UART, it prints that statement to UART 0. But here, like, we have used only UART print. Okay, so we have not used printf statement here. So the first thing is configure the port. GPIO. First, it is connected to the GPIO. Fourth, like, it is connected to GPIO, like fourth port. DHT11 is connected to fourth port. Only one line is connected. 4.0. It is connected to 4.0. Okay, 4.0. So you have to set the directions to clear. For direction DAR, this is to set. You have to define for a direction to set the pin, to clear the pin. Okay, and to give input, to give, like, to set it as 1. The port, and like for high it is 1, for low it is 0. Okay, you just define for high it is 1 and for low it is 0. And this is for pre-scales for timer, for delay, for introducing delay. And we have declared, like, the out of 40, like you have the data, like you have to the first thing is to configure the DHT11. You have functions to configure the DHT11, functions for initializing the DHT11, and function to receive bytes from the DHT11, and delay milliseconds and delay microseconds, and to initialize the GPIO. And this is to convert the integer to ASCII format. Okay, to convert the integer to void integer to ASCII is to convert to the same as like on LPC214. You have to convert the integer to ASCII format when you send the data to the UART. So in it, UART 0, UART print, and UART text. UART print is to print a string, whereas UART text is to print a character. Okay, so initialize the timer 1 and timer 2. So to initialize the timer, like, you go for the supervisory control, like so, and you set the pick on P registers, power control registers to turn on the timers. This is there on the data sheet UM1052. Like, if you check LPC_SC, okay, LPC underscore, I'll open the data sheet and I'll show you, like, okay, there it is. So if you check on EM10562, you just go for Control F. You search for peak on P. Okay, you search for the registers, like peak on P. Power control registers for peripherals. Okay, so this is the bit. This is the bit. This is the bit. So if for turning on the GPIO, you have to give 15. Okay, for UART 0, you have to give 3 to turning the power control. For the rest of the time it will be off, so that you could save the power, so that you could save the power, like this will be helpful, like whenever your device is battery operated. Okay, whenever the device is battery operated, I'll go for scale. Okay, so this is 22. Like, okay, for timer 2, to initialize timer 2, we should choose timer 2 is 22. Okay, timer 2 is 22, and timer 0, like timer counter 1 is timer of counter 1 is 2. Okay, for initializing the timer 2 and timer 1, it is the peak and P register is 22 and this is 2. Okay, and then you have to set the prescalers. These are CTCR and PR and TCR are the timer 2 registers. Okay, and these are the timer 1 registers. Have to send, and UART 0 configure 3 to UART 0. Set the, it is kind of to 0.2 and 0.3, 0.2 and 0.3. So to configure that as a GPIO, because it will be used as a multiplexed pin, like it may be a UART. Sorry, 1 is for UART, 0 is for GPIO. If you put 0 here, this 0.2 will be used as a GPIO. If you put 1, it will be used as the UART. Okay, so again, this will also be on the data sheet UM105, UM1052, like on the pin connect block. Okay, on the pin connect block, you will have to choose the UART, you have to put 1 IO context registers. And line control registers, you have to set the baud rate for 1,15,200 baud rate. Okay, so the value is 16, because 1 lakh, the UART module, the LoRa module will accept 1,15,200. The baud rate of the LoRa module is 1,15,200. So you have to make this Cortex M4 to 1,13,000 module. The peak clock is 30 megahertz. So if you substitute 30 megahertz divided by 16 into 1,15,200 module, you get the value 16 for DLL. Okay, divisor latch LSB. And divisor latch MSB is 0, and line control resistors is 3. Okay. This is the same thing which we explained on the same UART. This TXT UART transmit, you have to wait till the LSR, okay, line status register. If there's, and it loads the character, like whenever it loads that on the transmit holding registers. Okay, whatever the character is sent, like it put it on the TXR, like transmit holding register. And this is for string. To convert that to string, UART print is to print a string. It uses the same function of TXT here. Integer to ASCII, this is the formula for converting an integer to an ASCII code. Okay, this is same for everything. To convert a formula for integer to ASCII code. And to initialize the GPIO, you have to set pick on P to 15. And this is just for bringing this delay underscore milliseconds is used to make a delay by using timers. You could also, if you want to put a for loop also, you could also put a simple for loop that will work. Okay, delay microseconds, delay milliseconds, to create a delay for milliseconds, to create a delay of microseconds. And for config THT11, like you have to set the directions, set the THT11 high, and receive bytes. So receive bytes is the program, like whenever you send a start pulse. Okay, whenever you send a start pulse, like, and it replies back with 40 bits of data. Okay, so that will be on receive bytes. So this is for initialization. For initialization of DHT11, set the direction, GPIO direction, and set and clear. Make a milliseconds delay and make it high and low. Okay, so you have to give the receive bytes 4 times. Like you just receive the bytes like 40, like you will receive the bytes for 4 times, like, okay. So coming to the main program, like you initialize the DHT11, get the data. The first will be the humidity data, and the second will be the temperature data. Okay. You load the data, convert that to ASCII integer to ASCII format, and then you print the data to UART printer of display. So which is where this UART is connected to the connected to the LoRa module. Okay, this UART is connected to the LoRa module, and it prints the data. So let us check the program. I just compiled this program, and the process is same. The process of creating the program and the process of adding this C file is same. Like, and you go for Flash to recheck configure Flash tools. Okay. Else I will make a copy. Like, I just copy this code and I make a folder. I will create a new project. Go for new microvision project, and I just go for desktop. Make a folder called LoRa here. So LoRa, save this file. Choose NXP. Okay. How to choose NXP? LPC 4088. Click OK. Copy startup codes and add files to project. Yes. Click add new item to C. Okay. Click C file. Put LoRa here. Save this program. Okay. Click add existing files and just go for the C colon. C colon, like you just search for okay. Home and click startup. Click startup and click NXP and click LPC 4088. Compile this program, like you will get here, you get 0 errors and 2 warnings. Okay. So disable, go for debug, go for project, flash, configure flash tools, go for the output, not used. Okay. Click output linking, click linker, like use memory map is okay. Output, create text file. I choose a folder. Okay. I choose a folder called out. Click OK and save this program. Compile this program. Okay. Compile this program so you get 0 errors. I just open Flash Magic. Flash Magic. So before that, uh, I verify the comport on the device manager. The comport is 10. Okay. The comport is 10. Okay. 10. So I choose comport 10, browse. I go for desktop. I go for LoRa. Go for out. I choose LoRa.hex. Okay. And I put this bit on. I'm just reprogramming this code again. Like I click browse, I go for desktop, choose LoRa, uh, and then I choose this file, okay, LoRa.hex. I put this processor on programming mode, click start. So the device is programming now. Like once the programming is done, once the programming is done, like I just open the hyperterminal like X-CTU. I just open this hyperterminal. COM11, go for terminal. Okay, and I just reset this first. So you get the humidity as well as temperature data here. You could also view here like tools, go for terminal, go for COM, okay, and click OK. Okay, this is the transmitting end. Okay, this is the transmit player. Okay, so this is the transmitting and this is the receiving. We are receiving the data here. Okay, just transmit the data and the data has been received here. Okay. So I will explaining the hardware. Like I have connected the one I have connected. I just explain this hardware. Okay. I have connected one LoRa module to this my Cortex M4. The other LoRa module, like I have connected this to FT232. Okay. I have connected that to FT232. Okay. So if you check, I'll show you the connection. Like this is the LoRa module. Okay. So just connected to FT232. Okay. Just connected to FT232. Okay. This FT232 is connected to the PC. The PC. And I have connected DHT11 here. DHT11 on this code. Okay. So I will explain you the code. I'll explain you the code here. We have the first thing is to define the DHT11 and use timers. I have used timer 1, timer 2 for generating a delay of milliseconds and microseconds. I have configured this DHT11 and initialize this DHT11. Convert that to integer to ASCII format. You want print and you want text. Okay. And init underscore time to this for timer 2 initialization, timer 1 initialization, and init underscore UART0 for UART0. For UART0 initialization, UART transmit, UART print, integer to ASCII format, and to initialize the GPIO for delay milliseconds and for delay microseconds. So, and receive bytes for DHT11, and initialization of DHT11, and then the main program. So I initialize timer 1, GPIO, timer 1, timer 2, UART0, config DHT11, initialize the DHT11 here, get the data from DHT11, converts that to integer to ASCII format, set that to UART0. So, this is the program I have I have uploaded the program on the Learn portal. So with this I close the session and thank you for your time and thanks for coming on Sunday and thank